All right, so here's our startup number 1. It says find the value of the trig function indicated. It tells us sine theta. That means just in general for any given angle of theta. Notice that where theta is located. Theta is located right in here. So we want to find the sine function of that angle. Remember, anytime we're working with trig, we can go ahead and write our SOHCAHTOA. That way we know what's going on. That way we have an idea of which one we're looking at. We are dealing with sine. So sine is opposite over hypotenuse. So the sine of theta equals the opposite side over the hypotenuse. So opposite over hypotenuse. That would be the value. Now, a couple of things to remember here. We can just simply write the ratio there, but as you can recall, we never leave a radical in the denominator, so we have to simplify this and get that out. So the tens, of course, would cancel, but we'd have 1 over radical 2. Still cannot leave a radical in the denominator, so I have to rationalize. That means multiply both the top and the bottom. So that gives me radical 2 when I multiply straight across over radical 2 times radical 2 is radical 4, which is just 2. So therefore, there's my answer. Sine of theta equals radical 2 over 2. Number 2 says find the measure of each side indicated, round to the nearest tenth. So notice that we are looking for x right here. Now the angle B is 41.4. So this angle B is 41.4. So I'm given, in relationship to angle B, the adjacent side and the hypotenuse. So that would be cosine of B. Or we actually know what B is, so I need to write that in there. Cosine of my angle, which is 41.1, equals adjacent over hypotenuse. If it helps you out, write it out first. Cosine of your angle theta equals adjacent over hypotenuse. So that would be x over 13. And if x is on top, we multiply. So x equals 13 times cosine 41.1. And I would put that in my calculator. And rounding to the nearest tenth, x is approximately 9.8. Well, number 3 and number 4. Number 3, very similar to number 2, says find the measure of each side indicated, round to the nearest tenth. Once again, here's my angle. In relationship to my angle, here's the opposite, here's the adjacent, here's the hypotenuse. So once again, cosine of theta would equal adjacent over hypotenuse. So cosine 53 degrees equals x over 11. So this one would be worked just like number 2. X is on top, so we're going to multiply 11 times cosine of 53 degrees. We're going to plug that into our calculator, and x is approximately 6.6. And I say approximately because we have to round. Number 4, find the measure of the indicated angle to the nearest degree. So we are looking at this angle right here in relationship to my side, or to my angles. Here's the opposite, here's adjacent, here's hypotenuse. Once again, cosine of theta equals adjacent over hypotenuse. So we're looking for theta in this case. 34 over h, which is 35. Remember, anytime you are solving for an angle or solving for theta, theta will equal the inverse cosine of that decimal number when we divide the fraction. So I'm going to say 34 divided by 35. And if you need to, write it as the 4 decimal place number. So it's 0.9714. And I'm going to take the inverse cosine of that. So I have an approximately 14 degrees. So theta equals approximately 14 degrees because we round to the nearest degree. The inverse cosine of 34 divided by 35. Let's move on. Number 5 and 6. Number 5 says find each measurement indicated. Round your answer to the nearest tenth. Now notice that this is not a right triangle. In order to solve a triangle that is not right, we either have to use the law of sines or law of cosines. That's what we have to do here. So for number 5, we are finding YZ. We are looking for this segment length right here. That's what we're looking for. Now, angle X is 140.2. ZY is 17.1 and YX is 16.2. I am giving two sides and an angle. So that means that I need to use either laws of sine or laws of cosine. So we use the law of cosines in order to solve. And instead of saying that this is find YZ, if you want to just let it be a letter here, we're looking for A. So I'm going to use the law of cosines. So A squared would equal B squared plus C squared minus 2 times AB. Oops, sorry. 2 times BC. Cosine of angle A. Now my angle A is going to be the 140.2. So plugging in what we know, A squared equals, my B is 17.1, my C is 16.2, minus 2 times 17.1 times 16.2 times the cosine of 140.2. So this is our formula. Oh, sorry, left off my square right there. So this is my formula. I'm going to plug that into my calculator. I'm going to say 17.1 squared. That gives me 292.41 plus 16.2 squared is 262.44 minus 2 times 17.1 times 16.2 is 554.02. And then I'm going to say the cosine of 140.2 is a negative 0.7683. Then I'm going to go by order of operation and I'm going to start working things out. I'm going to say 292.41 plus 262.44. That gives me 554.85. Then I have to say 554.02 times a negative 0.7683. And a negative will be a positive 425.65. So combine my like terms. 554.85 plus 425.65 equals 980.5. And A squared is equal to all of these each time. So in order to solve for A, I have to take the square root of both sides, which is approximately A equals 31.3. Would be my solution for number 5.
It's okay.
Number 6, it says find each measurement indicated, round your answer to the nearest tenth. Once again, we're still solving for, or solving a non-triangle. We are looking to solve for z in this case. We are given two sides and an angle. Oh. I got to use the law of cosines. And since if I solve for z first, that would be two unknowns. I can't solve an equation with two unknowns. So what I need to do first is I need to solve for xz. I'm going to still use the law of cosines. I'm going to solve for xz first. And the way that I can solve for xz is I'm going to use the basis that these two are opposite of each other. So that would give me my a and my angle. So that would be 13 squared equals 7 squared. I'm going to call this y plus y squared minus 2 times 7y cosine 60. I'm going to start working that out. For number 6, it's not laws of cosine. We should just simply use law of sines. I'm sorry. We're looking here, and I've got the opposite side, and I'm looking here, I've got the opposite side. So I have the sine of 60 degrees over 13 is equal to sine of z over 7. And I simply cross multiply and divide. So I'm going to say 7 sine 60 equals 13 sine z. Remember, we can divide both sides by 13. I'm going to come right up here as I write. So I'm going to have 60, or the sine of 60, times 7 divided by 13 gives us 0.4663. That is equal to sine of z. But anytime we're looking for an angle measure, we're going to use the inverse of sine of 0.4663. So the inverse sine of that would give us approximately 28 degrees. Must have been in La La Land.